So today we are going to talk about the important definitions in electrical lighting design. What are the important things that we need? What are some of the important things that are needed in lighting design? So the following are some of the definitions we come across in the design of electrical lighting scheme. There's one thing called a utilization factor. When we will be dealing with a design, we will be meeting something called the utilization factor. So what is utilization factor or coefficient of utilization? It may be defined as the ratio of the total lumens. Lumens up when we talk about lumens here, we are talking about the lighting points. So it is the ratio of the total lumens received on the working plane to the total lumens emitted by the light source. That is the ratio of the total lumen received on the working plane to the total lumen emitted by the light source. So utilization factor lumen is equals to the lumen received, that is a lumen received over, these are now formulas that we're going to use. So they are very important formulas. So utilization factor is the lumens received on the working plane over the lumens emitted by the lamp. So not all lumens emitted by the lamp reach the working place. Some of them are lost by dispersion and diffusion, as we had learned earlier on in this unit. So the factor affecting utilization factor. So what are some of the things that affect the utilization factor, or what are some of the things that interfere or maybe brings to a change of the utilization factor? We have the things like the kind or the type of light. That is it a natural light? Is it a fabricated light? Is it a reflected light? So the type of light is something that can affect the utilization factor. The light fitting, for example, a fluorescent tube will not emit the same light as a downlighter. So the type of light fitting, the floodlight will not emit the same light as the normal round bulbs. So this type of fitting, the light fitting, also affect the utilization factor, meaning that utilization factors will be different for different types of fittings. And then we have the color, surface of the wall and ceiling. So at times, rooms that are painted darker than others will have a different utilization factor as compared to rooms that are bright. So the color of the surface also matters and brings about the difference in the utilization factor. Another thing is the wall, the ceiling, the color in the ceiling also affects. So if we have bright ceilings, they increase the amount of light in the room. And if we have dark ceilings, of course, they will reduce the amount of light, hence affecting the utilization factor. So utilization factor is a very important concept during the calculations, and we'll be using them in one form or the other. Another kind of thing that can affect the utilization factor is the mounting height of lamps. The mounting height of lamps, meaning the height at which we mount the lamps, that is the area to be illuminated. The height is a factor that affects the utilization factor, because the height is also something that we are going to put into consideration when we are doing the design. Important definition number 2 again is the depreciation or maintenance factor. It may be defined as the ratio of illumination under normal working conditions to the illumination when everything is clean or new. Now, it is defined as the ratio of illumination under the normal working condition. It is the ratio of illumination under normal working condition to the illumination when everything is clean or new. That is now called the depreciation or maintenance factor. So the DF or the MF is equals to the illumination under the normal working condition over the illumination when everything is clean. So under normal working condition, you ask yourself, what is normally the amount of illumination that is there, and then you divide with the illumination under a clean or an adjusted environment. So the maintenance factor is based on how often the lights are cleaned and replaced. So if we clean our lights more frequently or most times, so it means that our lighting will also be improving as we clean, and will not replace all the time. So it takes into account such factors as a decreased efficiency, with age, accumulation of dust within the fitting itself, and the depreciation of the reflectance as walls and ceiling age. So for convenience, it is usually given as the three options. So we can have the depreciation factor as good, which is a factor of 0.7, then we call that good. Then when it is medium, it is a factor of around 0.65, and then when it is poor, it's a factor around 0.55. So in your examination, you might be asked to calculate the utilization factor, or even calculate the depreciation factor, or you can be given these factors and told to calculate the illumination. So you'll need to understand all of them. And then we have the waste light factor. So when a surface is illuminated by the number of lamps, so there are a certain amount of wastage due to overlapping of light waves, and this value will be between 1.2 to 1.5. That is called the waste light factor. Another one is the reflection factor. Reflection factor is also another factor that can affect lighting. So it may be defined as the ratio of illumination of flux leaving the surface to the luminous flux incident on it. So its value will be always lesser than 1. The value will always be lesser than 1. Absorption factor. When an absorption is full of snow or smoke fumes, it absorbs some light. Hence, absorption factor may be defined as the ratio of the net lumens available on the working plane after absorption to the total lumens emitted on the lamp. So its value varies from 0.5 to 1. Another thing is the luminous efficiency or specific output. The luminous efficiency or specific output, this may be defined as the ratio of number of lumens emitted. So these are formulas that we are going to use. It is the ratio of the number of lumens emitted on the electric power intake intake of a source. So it is the units in lumens per watt. So that is called the luminous efficiency or the specific output factor. Another one is the space to mounting factor. The space to mounting. Sorry, this thing is going back. The space mounting height ratio, that is the SHR, is the spacing between the luminance divided by their height above the horizontal reference plane. So the spacing to mounting height, that is the SHR, is the spacing between the luminaries divided by their height above the horizontal reference plane. The room index. The room index is the ratio described by how the room height compares to its length and the width. So it is given by the room index is the length times width over the height. Let me zoom it out. The height into length plus width. This is also a formula that we will be using most frequently. That is the room index. Now, where L is the length of the room, W is the width, HM is the height above the workplace. Now, the Lumen method steps. We have steps for calculating uh, uh, the amount of lighting, the amount of illuminations. Meaning, we are calculating the amount of lighting points that are needed in a room. So there are methods that we'll use. There is one called a Lumen method. So it has the following steps. Step number 1 is find the required lux level. Find the required lux level. Another one is select the luminaire, then determine the room index. Find the amount of lux. So determine the number of fixtures. So now we are determining the number of fixtures. The formula is N is equals to E times A over F, or times the UF. That is the utilization factor. Yes. Yes, Salad.
Hii ni second slide, sio? Hii ni second slide.
Hapana, tuko tu bado ya kwanza.
Second slide. Nilikuwa nimeona lakini nikarudi sai. Nadhani ni second slide. Madam,
Yes, Salad.
nasema
Mm.
tuko kwa second slide, si ndio?
Hapana, ni ile ya kwanza, bado sijaenda second. Kwani ulienda wapi?
Nimeenda choo nikarudi, nikaenda choo haraka haraka nikarudi.
Ulikuwa umefika
Second.
page gani? Ulikuwa umefika page gani? Nirudie.
Nimefika hapa wastage light.
Acha nirudi. Hapo.
Hapa.
Sawa. Let me just repeat again.
Asante.
Sawa. So tulikuwa tumesema these are the factors. We were talking about the important factors that are needed for a lighting design. Tukasema kuna utilization factor, tukasema kuna the depreciation factor. Depreciation is the rate at which a light fitting will reduce. That is, it will reduce or it will stop working, or it will stop its efficiency, also called the maintenance factor. So it is defined by the ratio of the illumination under the normal working condition over to the ratio when everything is clear. So another one is the waste light factor. The waste light factor, I said, it's when the surface is illuminated by a number of lights. There is a certain amount of wastage due to overlapping of light waves. So this value will be between 1.2 to 1.5. So that is the waste light factor. And then we went on and said we have also a reflection factor. So then we asked, what is a reflection factor? A reflection factor is a factor. It may be defined as the ratio of the luminous flux leaving the surface to the luminous flux on it. So the value will be always less than 1. The value will be always less than 1. And then we went ahead and talked about the absorption factor. So absorption factor, is when the absorption is full of snow or smoke or fumes, it absorbs some light. Now, hence, absorption factor may be defined as the ratio of the available on the working plane after absorption of the total lumens emitted by the lamp. So it varies. Value varies from 0.1 to 1. So the luminous efficiency or specific output. So it may be defined as the ratio of number of lumens emitted to the electric power intake of the source. So that is the luminous efficiency. And I said we are going to use all this formula in our calculation. And then we have the space or mounting height. That the space or mounting height is also another factor or another figure that we'll be using. So the height is very important. We will have to know that the mounting height will affect the amount of light that reaches the working plane. Another thing that we'll use is the room index. The room index is the ratio described how the room's height corresponds to the length and the width. Now, the room index will be calculated by the length times width or divided by the height from the working plane times the into bracket times into bracket length plus width. So this is also another important formula that we'll use in the calculation, where L is the length of the room, W is the width, H is the mounting height above the working plane, and the Lumen method steps. So find a required lux level. Now select the luminaire, determine the room index. So we are going to, some of the methods that we're going to use in calculation. One of the method is the Lumen method, and in the Lumen method is going to help in the calculation. It does the following steps: finding the required lux, and then selecting the luminaire, and then determining the room index. So those are the steps that are involved. So we have now determining the number of fixtures. So finally, when you want to determine the number of fixtures, so the formula will be number of fixtures, that is the number of lighting points in a room, is determined by E times A over F times UF times MF. So what is N? Our N is the number of lamps that is required, or the number of lumens. And then E is the luminance. Sorry, let me respond to this. Okay, now let us proceed. So I said this is the formula that we are going to use. This is the formula that we're going to use. That is N is the number of lamps required. E is the luminance, that is the level required, that is the lux. And we said that the first step in calculating this is calculating the lux, and then the area of the working height or plane is meters squared, and then the average luminous flux F is the average luminous flux from each lamp, that is Lm, which is normally given. Edgar, please mute your mic. Okay. There's a disturbance. Let us proceed. Okay. So UF is the utilization factor, and we said the calculation of utilization factor we had given it there. It is the amount of lumens emitted that reach the workplace divided by the number of lumens that are emitted from the source, and then we have the maintenance factor. So another thing that is going to assist us in this calculation is determining the minimum space between the lumina. So how can we determine? So that is the minimum spacing, that is the space and the height ratio, that is the times HM. So HM is the mounting height and SH is the space to height ratio. So another thing that we'll do is to determine the number of the required rows of luminae along width of the room. That is the number of the required rows width of the room and the minimum spacing are also things that we'll calculate. Again, we also determine the number of luminous in each row. We'll also calculate, that is, how can we get the number of luminous of each row is the total number of luminal divided by the number of rows. So all these things we are going to calculate, and you can be asked to calculate to use any of the formulas that are given there. The actual spacing along the luminance, the actual spacing length of the room, number of the luminance in each row, the transverse spacing between the luminance, transverse spacing within the room, as you can see. So the structured design. So there are seven steps in lighting design process using the structured design. So now identifying the number of requirements, determine the method of lighting. These are some of the things that we are going to use in the calculation. Give me like 3 minutes to change to the phone because my laptop is not working well today. Just give me like 3 minutes. I change to the phone. Okay, let me save the users. Okay, now I was talking about the things that we need in the design, and now we are here. I want to zoom this. Today I have problems with my screen. I don't know why, but anyway, it is coming. So okay, there it is. So some of the things that we need to do before doing a design, I said that we have to select the lighting equipment, we have to calculate the lighting parameters and adjust the design as required, we have to determine the control room, and we have to choose the luminaire. Then inspect the installation upon completion, and if possible, few months after occupation, to determine what worked and what didn't. So this is the only way to build the experience and to apply for future design. So when we are working using these illuminators, and then we want experience because we are working over time. Sometimes you will just finish school and you want to enter or you want to get into the design system. So you ask yourself, if I want to enter into the design system, how are companies need people who are experienced? How am I going to place myself in the market? So doing this, some of these things, knowing how to calculate, starting all the way from campus, knowing how to do these things, working it out with your friends, doing practice, it brings about the experience that is needed. So identifying the required requirements, this involves gaining a full understanding of what the lighting installation is intended to achieve. So this includes the following, that is the task requirements: luminance, glare, mood of space, a relation to space, to shape of space, things to be emphasized and things to hide, direction, light, and interaction of the light. I've already given you several formulas that will be used. So determine the method of lighting. So you have, and this is another stage of now determining the method of lighting that you want to use. And at this stage, a consideration is given to how the light is delivered, e.g., will be recessed, surface mounted, direct or indirect, or will will up lighting be used. So in this, primary characteristics will be primastic. Uh, uh, Sometimes, if you want to write a message, you just unmute your mic and talk because I will not be seeing the messages. I'm zooming the screen so that you can see well. Okay. Let it come back again. Good. So consideration should be given at this stage to be used by daylight to minimize the need for artificial lighting. So select the lighting equipment. That is the next step of selecting the lighting equipment. Now, selecting the lighting equipment, sometimes it is affected by several characteristics or several factors. So one the method of lighting has been selected, the most appropriate lighting source can be chosen, followed by the luminance. That the following attributes should be studied when choosing the light source. That is the light output in lumens, the total input voltage, the efficiency, the lumen power, the lifetime, the physical size. All these have to be kept in consideration because in the efficiency you shall have calculated the it is also the efficiency. You shall have calculated the lumen power and then the physical size. We have the surface, brightness and glare. We have the color characteristics, the electrical characteristics, the requirement of the control gear, compatibility with existing electrical system, suitability of the operating environment. A number of factors also affect the luminance choice. So characteristics of the light source and control gear. And then we have the luminance efficiency, that is a percentage of lamp light output transmitted out of the fixture, and then we have the light distribution, the glare control, the finish and appearance, and then the size. We have also to consider the availability of the components for maintenance. Meaning, if I'm choosing a light like Chandaria, I ask myself, if maybe the light fails, will I be able to access a components that will assist me in maintenance? We also have the acoustics, we have the thermal management. There's some of the things that have to be put into consideration. Then the calculating and the lighting parameters, we have the lighting calculations methods fall into three broad categories. We have the manual calculation method, the three-dimensional modeling method, and three-dimensional modeling method is normally done using softwares that are, and we have the visualization. Sometimes you walk into the room and you look at the room and you decide that I'll put one light here, one light there, and one light there. So you don't even need the software. So it depends with what you have at hand and how big the project is, because some big projects you cannot use visualization, like now story houses, you have to do the calculation. Some of them, for these advanced companies, they use the 3D modeling, where they have a software that they put in that you can be able to even be able to fix the lighting for them. So the photometric data for lighting sources and luminance in commercial is commercially available to contribute to these calculations. So the manual calculation method, how does it happen? This is a wide range of manual computation methods of calculation of different lighting aspects. So this manual method is what we are going to use for our examinations, because we not use the software method. So we have to use the manual method. So this manual method, this includes the complex methods of calculating the illuminance from a wide variety of shapes of luminous objects, and the majority of these have now been suspended by computer programs to check these are software. So Lumen method is the mainstay from the interior lighting and has remained the use quick, relatively accurate method of calculating the interior luminance. So the luminance method calculation is the average luminance of a specific level in the space, so including an allowance for the light reflected from the interior surface of the room. So the calculation method has a set of assumptions that, if followed, gives the reasonable visual environment. So inadequate attention to the assumptions will produce the poor results. So the basic assumptions are, number one, we assume that all the luminance in the room are the same and have the same orientation. That is, if we choose to put fluorescents, then we choose that the whole room will use this fluorescent. Or if we choose to use even the downlighters, and then we decide that all the lightings in the room will use the downlighters. And then the luminance do not have directional distribution and are aimed directly to the floor. That is another assumption that we assume. We also assume that the luminance are arranged in a uniform array on the ceiling and have the same mounting height. And we also assume that the luminance are spaced less than the maximum spacing on mounting height ratio limited in the coefficient of the utilization table. So the average luminance are produced by the lighting installation, or the number of luminance required to achieve the specified average luminance, can be calculated by means of utilization factor. So the utilization factor that we had calculated being the ratio of the total flux received by a particular surface to the total lump of flux. So the total flux received by a working surface is divided by the total amount of flux that a lamp can emit. So the Lumen method formula, and that is what that I had given you that time. Lumen method formula is that. So all these are, or you can use this formula or the other one that I gave you. All of them will bring to the same answer. So the F is the measure of bare lamp flux that is in lumen, and then N is the number of lamps per luminary, and N is the number of luminaries. And then LF is the total light loss factor, and we talked about the loss factor or wastage factor. And then the UF is the utilization factor for the reference surface of the lucent luminance. So utilization factor can be determined for any surface or layout of the luminance. So the UF symbol is normally shown followed by an extra light in a bracket to denote the surface. For example, the UFF is the utilization factor of the floor cavity, that is the UFW for the wall cavity. So utilization factor are in practice only calculated for general lighting systems with regular arrays of utilization and of the three main room surfaces. Of the three main room surfaces, and then now the lowest surface, that is the F surface of the floor, is the horizontal plane in the normal working height, i.e. the table height, which is often assumed as 0.85. So when you get yourself in this field of design and calculation, you will be able to get used to these things by using this. So although the lighting designer can calculate utilization factor, lighting companies publish utilization factor for standard conditions for their luminaries. So the standard method of presentation is shown below. We have the method. So we'll be able, with the use of the table, the table was not there. Let me get the table. So you can now see this is an calculating down now the room index. Sorry, let me see slide 8. Okay, seems the table was not captured, but we'll still proceed. So you can now see room index calculation. If you want to calculate the room index, you can see the walls here. You can see the walls, you can see the luminal plane and the ceiling cavity, and you can see the floor cavity and the horizontal plane. So room index is the measure of the angular size of the room. That is the length, the width, the height. That is the room index. And the ratio of the sum of the plane areas of the F and the C surface of the area, the width of the surface, that is the floor and the ceiling surface, the area of the walls of the surface. So the rectangular room index is given by, so room index is the length times width over W, length plus width into times HM, where we say that HM is the height uh, of the room from the working place. So this is a very important formula in calculating the room index. You will get these things on site when you will be able to find yourself in this field. So if the room is a reentrant in shape, for example, L shape, then it must be divided into two or more non-entrant sections, which can be treated separately. So spacing to mounting a height ratio. That is another ratio that is very important. That is the spacing to mounting height ratio is the spacing between luminas divided by their height above the horizontal reference plane. So it affects the uniformity of luminas on the plane when the UF of the tables are determined for a nominal spacing to height ratio, that is SHR norm, the maximum spacing on the height ratio, maximum of the lumina is also calculated and is a value that should not be exceeded if the uniformity is to be accepted. Visualization. Visualization is another method that we said that we can use in calculation. So in visualization, this is the process that creates perspective rendering of the surface in level of detail that vary from a block representation of the space to a photographic quality renderings. So depending on the sophistication of the program and the level of detail of the interior to be entered. So the program will fall into two basic types, that is the flux transfer or radiosity calculations and the ray tracing calculations. So the major difference between being in how they interpret light from reflective surfaces. We have now, as you could remember, as we calculated the rules, the laws of illumination, and one of it was the Lambertian laws. So the Lambertian surface is a perfect diffuser where light is reflected in all directions, irrespective of the angle of incidence of the lighting surface, that irrespective of the viewing of the angle of the surface, has the same illuminance. So a specular surface is a mirror-like surface where the angle of reflection and the light is the same as the angle of incidence. So you can see this is on the bottom surface, that is the middle specular surface. Right is the semi-specular surface. So the real life surface is a combination of both surface, semi-specular, and has both specular and diffuse characteristics. So some materials are more specular while others are more diffuse. A flux transfer or radiosity program treats all surfaces as diffused or Lambertian surfaces. As a result, their rendering tends to appear flat with soft shadow details. So it will tend to overestimate the uniformity ray tracing. It traces individual rays of light from the source to the eye as it reflects from the surface or the surface around the room. So as a result, ray tracing can allow for the specular component of the surfaces. Can allow for specular components of the surfaces. So finally, we have some programs that calculate the entire lighting by ray tracing. So while others calculate the space of the flux transfer basis and have the overlay tracing of the quality of the rendering. So when ray tracing is added, reflections are added in polished surfaces and shadows become sharper. So visualization programs are a useful tool in the presentation of the design. So it is a tool of design to check that the design is consistent with its own visualization of the space. And to model specific lighting solutions, the programs are still calculation tools in all design programs. So the program can show the designer how a specific design will perform, but that they cannot reliably be used to assess the executability of the design. So the output should be number one, installation information, that is the type of location and luminance and the aiming and information. The lamp details should be included as well as the specific catalog and numbers. Another one is the light technician parameters, that is the illuminance and uniformity and other parameters that have been calculated to achieve the design. Another one is the verification information also is needed to be presented in the report of illumination. Okay, now that slide is done. So I'm going to present the last slide that we need. I don't know what is wrong with my screen today. Needing another slide. Okay, so we have this. Today our visible button is very stubborn, but we will manage to finish the class. Okay, I'm now there. The light design consideration. Or I said that today we are just going to look at the consideration, the things that we require in the design. After finishing with the consideration, next week we'll start the calculation. We'll start with the introduction of the calculation, and the other week we'll be doing more calculations, and we'll be doing practical calculations to see how exactly we can be able to get the number of lighting. So lighting design application or design. This chapter is going to discuss the methods and tools needed to produce an integrated lighting application that use advanced sources, luminance, and controls. So the reviews of lighting design process, including issues of lighting quantities as well as lighting levels, are presented in series and 19 guidelines for designing advanced lighting systems. Now, examples of advanced lighting applications for private offices, open offices, executive offices, classrooms, several types of retail spaces, and the outdoor application. So these examples demonstrate how the advanced technologies can be integrated, that is, in the day lighting in some cases, produce a high efficient and quality applications. So we have the lighting and design and redesign process. So design means is the science of the art of making things useful to humankind. So the lighting design is the application of lighting, including daylight when it is specifically used as a source of lighting to human space. So unlike architecture, engineering, and other design professions, a lighting design relies on the combination of the specific scientific principles, established standards, and conventions of the number of artistic, cultural, and human factors applied in in the artful manner. So in this field, it has it been moving, and it has been improving or developing with time. So lighting quantity, setting the criteria ratio. So some of the things that we need there is it is the most widely used and accepted method of determining the light levels and application. This method consists of the following: choosing an acceptance luminance according to the categories, and then all through with being the lowest and G being the highest. So the instance of luminance associated with the categories. And then adjust the actual design level according to the task and human factors. The design are strongly encouraged to make informed adjustment to the criterion light level. For instance, the category D, one might choose 20-foot candles for school children and 50-foot candles for seniors. To make the correct adjustment, the designer should be aware of the occupant's age, the specific task to be performed in the space, and the extent to which the daylight affects the space. So the presence of other tasks like a computer or adjacent workstation also needs to be taken into account. Now, determination of the lighting levels is critical. Choose the levels too low, and the success of the project may be at stake. Choose too high, that is too high, money is spent. Factors that take into account include adaptation level of the viewer. That is, when night is adapted, the person typically will need lower overall light levels than when the daylight is adapted. And then the viewer's age, the people who are using the room, also the age should be considered. The visual size of the task, that is the very small task, or the measured the visual angle according to the amount of task that is needed to be done. And also the interaction of the task, that is the specific needs of adjustment task may be appear to conflict, but recognizing that the light level recommendation are needed. Lighting quality again profoundly affect many humans' reactions in the environment. These human reactions range from the obvious, such as dramatic beauty of the illuminated landmark, or the emotional response of the candlelight dinner. So, in short, what we are talking about here is the things that we have to consider. The things, most of these things, we have talked about them. Then, the things that we have to consider when designing these. Now, lighting distribution, including the task, ambient light, the daylight integration, the spacing, workspace consideration, the flexibility, the appearance of the space, the color appearance, the luminance of the room surface, the flickering light, the direct glare. And we say that glare is another thing that we have to make sure that it does not happen in our lighting things. And then the lighting of people and objects include the modeling phases and that. Now, light distribution, it is a task and ambient light overview. Most common lighting design for commercial spaces has long been general lighting, in which a single type of lumina is laid out in a more or less regular grid or pattern, producing a relatively uniform illumination throughout the room. So all these are very important aspects in the design of the luminaires. Then the ambient requirements, the ones we don't need them now. The advanced gas line, that is the tax required. So up to that point, we have covered the basic concepts that we need during the illumination. The basic things, these are now what I was talking about, the daylight integration. So when we'll be calculating, you will be able to see how we'll be putting into context all these factors that affect the amount of light that is illuminated to the surface. Okay. So we are done up to that moment. And I would like people to ask a few questions before we can break for discussion. Unmute your mics. Yes, I want to hear people ask questions. Yes, Edgar.
Kwa sahii sina swali madam.
Yuko sawa? Yes, yes, Salad.
Yes, madam. Kwa design procedure kuna PowerPoint for giving room, rating of a light and power circuit. Hiyo ni calculation ama?
Calculation ni hiyo tu ya kucalculate the lighting points and power points.
Na rating of a light.
The rating of light. The rating of a lighting is like the luminance, the lux that kind of fitting in a beba. When we'll be calculating, utaziona tu itajitokeza yenyewe. So from next week nataka tuanze hizo calculation. I didn't want us to start today because leo nilikuwa nataka niweke formulas. So hizo formulas zenye nimewapatia, make sure that you have them na mmeshazi practice. So by the time tukianza calculation, nikiwauliza formula fulani mnaniambia. So that is why I gave you the formulas today and the conditions and the recommendation or the requirements during the calculation. Sawa.
Yes, I have a question. Kiasi tu.
Yes.
Kiasi. Kuna circuit diagram of designing procedure. Hiyo diagram ni gani?
At circuit diagram of what?
Designing procedure. Ukiangalia
Designing.
kwa course outline. Ukiangalia kwa course outline alafu kuna under designing procedure kuna circuit diagram.
Circuit diagram. Circuit diagram of designing procedure, unajua hizo tulishafanya. Unajua circuit diagram ni gani, Salad? It is the installation diagram ile tulikuwa tunachora nyumba kama ni 3 bedroom and then we put some lights. Tunasema hii tutaweka taa hapa, tutaweka taa hapa, tutaweka. Unajua we were putting the lighting points bila kufuata a procedure, bila kucalculate. But now we are going to calculate so that wakati tutakuwa tunaweka circuit diagram, tunaweka now depending on the calculation. Tukisema this is the number of lights and this is the number of rows, so we can now put them depending on how we have calculated them. Sawa?
Okay, alafu kuna hiyo ya kufanya conduit layout for lighting and power circuit.
Conduit layout, sasa hiyo ni wewe tu ndio unajua, hiyo ni kutumia tu basic thinking. So kama wire zitapita hapa, si conduit pia itapita. It is the ability of you to be able to calculate the amount of conduits that can fit in a building. And we did that. I think we did that when we were starting estimation. Wakati tulikuwa tunatengeneza business BQ. Si tulisema hizo?
Lakini mimi nauliza. Unaona hiyo pictorial chart? Ya unachoroa floor alafu ground.
Inaitwa schematic diagram.
Yes. Alafu alafu una key pia unapatiwa conduit lay and wiring complete, conduit lay wiring complete and accessory fit.
Kama ile yenye tulifanyanga kwa class.
Tulifanya bill of quantity.
Kuna nyingine tulifanya kwa class kama hiyo tu yenye unauliza. Ama ilikuwa ni group nyingine tulifanya na wao?
Group nyingine, group yangu bado.
Sawa. Unajua vitu mingi we will get them when we will be revising. Nataka tumalize, tuanze kurevise hizi past papers. Tunasema kama ni siku fulani tuna revise papers za hii siku. So tuanze hizo revision mapema so that tuone ni nini hatujakava.
Nitakutumia kwa WhatsApp hii swali sababu ni 8 marks.
Sawa, utanitumia, but it is a very simple question. Utanitumia tu alafu nitawajibu hapa.
Sawa.
Alafu pia ni vizuri uscan hiyo swali uweke kwa discussion. Unaona kwa discussion ukiweka kila mtu ataona na nikijibu hapo kila mtu ataona.
Nitaweka hapo kwa sharing notes ama?
Si una scan tu alafu una attach. Ama itakata.
Ikiwa class inaendelea.
Si huwa nina create hiyo discussion mapema. Na siwekangi time, so siifungi, unaweza ingia anytime.
Sawa. Nitajaribu hivyo.
Sawa, ukishindwa unaweka tu kwa WhatsApp, nitaona.
Sawa.
So, nataka tuende for discussion. Is that okay?
Yes.
Nataka tuende discussion, alafu tukimaliza discussion, sasa tutajipea break, we go for lunch and then we come back at 2 for EMFD. Si ndio?
Sawa.
EMFD pia mnakumbuka tuna